I'm Santi. I'm from Argentina. I don't know if you know Argentina, but it's like super far away in the end of the world at the south. I really like traveling. I am almost something like a digital nomad, so I stay a lot in Europe, but I like to go to Patagonia when summer because I like mountains and all that stuff. Apart of that, I'm a cloud engineer and incident responder. I've been working in cloud security a lot of time, and I have seen different stuff. And the idea of this presentation is a technical presentation, a demo drive, and I have 2 slides, and the rest is going to be demos. And what I'm going to show you is some technical applications of not common attacks that will allow us to understand how our log collection engines and our detection strategies work in the lower level, and what can attackers do to bypass them, and especially to exploit misconfigurations in AWS to take advantage of those delays and blind spot to make our life harder. The difficulty with this kind of attacks is like they are going to be built on our false sense of security. So if we're not tracking those, the most typical thing that would happen to us is that we are going to have false negatives, and those are the worst that we can have. This is the name of the talk, and I think this is the most important presentation of the talk. This is how all logs are generated in AWS and all the possible integrations that you can do to the SIEM. Basically, I have like here 2 services for you that don't know about AWS. The first one on the top left is AWS Guard. This is a threat detection tool that has custom detection rules built in and will correlate a lot of events from API calls, DNS, network logs within AWS to generate alerts. It's a one-click button enable tool, so it's great and it's super easy to implement, but it has some difficulties, like you cannot create custom rules upon it. So you are stuck with what AWS gives you. And as we are going to see, it's really easy to evade it, right? The second service is Guard. This is the bread and butter for doing incident response in the cloud, because it's going to log every API call that happens to whatever you're using in AWS. In the cloud, every service is an API. So if I'm creating a user, I need to call an API. If I'm creating a server, I need to interact with an API. And all those interactions are going to be recorded with CloudTrail. Where you are seeing CloudTrail there, you can introduce a ton of other different logs that you need to enable. The 2 ways to send data to a SIEM are like sending the data to an S3 bucket and then let the SIEM poll it, or have a Lambda function to push that data to the SIEM, and that can have different delays. From CloudTrail to the S3 bucket, you can have up to 15 minutes of delay. And that's awful, because imagine that you are creating a real-time detection rule that is going to interact with a SOAR or whatever, or you are trying to correlate the CloudTrail event with other stuff, and you can have like a 15 minutes old event in the bucket. If you use CloudWatch logs, it's the recommended way of doing that. It has up to 5 minutes of delay, but the difficulty is like most SIEMs doesn't allow the integration with this implementation. So it's up to you to understand if the SIEM you are using allows you to do that type of integration, and understand what are the risks of what you are doing. Then there are other delays that are introduced by the SIEM itself, like for how long they are polling the events. Some SIEMs, like Splunk, allow you to create custom polls, like 1 minute, 10 minutes, or whatever. But QRadar, for example, polls by default on every 10 minutes. So you have the 15 minutes of CloudTrail plus 10 minutes of QRadar. That can be like super messy. These are all the logs that you can generate in AWS. There are a ton. So every service can allow you to generate custom logs like load balancer, API gateway, Lambda functions. But again, AWS is not going to handle them for you. You need to enable them, ship them to an S3 bucket, then integrate those to the SIEM, and then make the parsers, normalizers, and all that stuff with all the same delays that we were talking in the last slide. This is the last theory slide. This is the shared responsibility model. I think this is the first thing we learn when we are doing an AWS training, and I think it's the most important thing. The shared responsibility model specifies which parts of the cloud are managed by you and which parts of the cloud are managed by the cloud provider. This is true for every cloud provider you're using, no matter if it's Azure, AWS, or even GitHub, Discord, or whatever cloud services you're using. There are going to be things like if you're using a server in AWS, the networking is going to be on your side. The administration of the server is going to be on the AWS side of the physical part of the server, the switches and all that stuff. But the operative system is on our side. So every service has this different set of responsibilities that we need to learn in which part of the field is it happening, if it's in our side or if it's in the side of AWS. This is especially important with services that are PaaS services. Those that we are relying a lot more in the AWS security strategy, because if we haven't hardened those services well, we are not going to be able to implement security controls. One example is with AWS Lambda, that is a service that allows us to execute code in a serverless fashion. We cannot implement an EDR in the Lambda function. We cannot implement anything because the Lambda function is ephemeral. It's going to live for 15 minutes and then it's going to die. So as we cannot do those things, we can create Lambda functions without network connections that can go to the internet without being monitored. So if we cannot implement an IDS in the middle of the Lambda function and the internet, if we cannot implement a proxy or whatever, there are a lot of controls that we are going to be missing, and we are going to exploit them. The objective of this presentation is for you to understand those points, those blind spots, and try to understand what's the best approach to harden your defenses. No matter if you don't understand or if you are not an expert in AWS, these concepts are real for every cloud provider, and the important thing are the concepts. The attacks that I'm going to do, this is the disclaimer, I need to have permissions to achieve those attacks, are for this presentation purposes, and it's not as trivial to execute these attacks in a production environment. And again, the important thing is the concept. Don't bother about the attack itself. So we are going to do three things. First of all, we are going to enumerate and work with something that's called global endpoints. A global endpoint is an API that I can access from different regions, because AWS has data centers around the world. So if I have my production environment in the US, I can execute API calls to the API that is hosted in, for example, Stockholm or, I don't know, Paris. If I do that, the logs are going to be generated in different ways based on the endpoint that I'm executing. If the endpoint is regional and I execute an API call to Paris, I'm going to get the data in the data center in Paris. But if I execute an API call to a global endpoint through Paris, I'm going to get all the data, but the log is going to be generated in Paris. So if you are not monitoring Paris, you are not going to see that log, and you are going to have a false negative. There are other endpoints, like the IAM endpoint, that is the most important one, that is going to always log in North Virginia. So if you execute an API call, or if you have your production environment in Paris, and you're not tracking North Virginia because you don't have anything there, you're going to miss all the administration of the users in the AWS platform. Then we are going to exploit a blind spot using the Lambda function. I'm going to show you how with 10 lines of code we can build a backdoor and we can execute API calls against AWS. This is the architecture. I'm going to use an API gateway, a Lambda function, and again, a Docker image. But we are going to talk about this later. I'm going to change to my computer. So here I have my terminal. So I can execute a CLI command that's called AWS S3LS. This is going to show me all the buckets storage in my account. But if I execute the same API call in EU North 1, that is another region, I'm going to get the same information. I was using the different profile. This is the one that is going to be executed in North Virginia. And this is the one that I'm executing in Stockholm, right? So I'm getting the same information because it's a global endpoint. It happens the same with AWS STS get caller identity. That is the who am I in AWS. If I execute this, I'm going to get the user that I'm executing API calls against, right? These logs are going to be generated in Stockholm. And if I show you, for example, CloudTrail, this is how you can see CloudTrail. CloudTrail has this thing that's called event history that allows you to see all the logs of everything that you are doing against the API call. I can search by username. I'm going to see all the logs of things that are happening in North Virginia. But if I change my region to Stockholm, we are going to see much less events. What's this? Because this region is not enabled, right? This region is not used. It's not a production-ready region. So it shouldn't have data here because nobody should be using it. AWS has also another security boundary that's called organization that allows you to restrict who can access to each region. This region is blocked with AWS organization. I can show you that trying to access Garduti. If I want to access Garduti in the Stockholm region, I'm not going to be able because it's blocked with a security control policy. This is extra dangerous because this region shouldn't be enabled. I shouldn't be able to generate logs in this region. I shouldn't be able to execute API calls against this region. And I can also, I cannot even see CloudTrail if I don't change the region like I did. So this is extremely dangerous, especially for attackers that want to enumerate our environment without or test if the API keys that they were able to install are valid. What can we do to prevent this? Well, I think yesterday I saw a nice presentation about cyber deception. We can use this to generate alerts on our behalf based on logs that shouldn't be here, especially with logs that compromise or can be are associated with enumeration. So we need to take this into account. The same happened with the IAM, right? I am going to show you here, I'm going to go back to Sao Paulo, that is the region that I'm using for my production environment. I'm going to show you Garduti. As you can see here, I have Garduti enabled. This is the front end of Garduti. I don't have findings, I don't have any alerts in here. I have something that's called Lambda protection that I'm going to enable, that this should be up and running to prevent everything happening in the Lambda function. I also have here my Lambda function that is the one that's going to be, it's going to run my backdoor. As you can see here, it's based on a Docker image. Why I did that? Because normal Lambda functions, you can see the code in the presentation. If you use a Docker image, the incident responder should have to access the Docker registry, download the image, know how to run the image, and they need to add another skill that not most of us have. I'm going to expose this backdoor using something that's called API Gateway. Why I'm going to do this? Because API Gateway allows me to connect a an endpoint with my Lambda function. And also provides me with a nice URL. And the URL has an Amazon domain. So what we are trying to achieve is like to execute the API calls as I did with the S3 bucket, but from wherever we want, making the API calls looks like they came from inside AWS, and if somebody is monitoring my network, they are going to see an outgoing call to AWS because it's going to go to an Amazon domain. If we go back to Stockholm, and try to analyze the log that we were trying that we generate in Garduti in CloudTrail, we are going to see that CloudTrail allows us to have a lot of information. The log is super verbose. We can see the IAM user, we can see the source IP, we can see the user agent, but it's like a big log. Most companies, what they do is try to reduce it to make the SIEM not be as heavy, right? If I do an IP lookup, I'm going to see I'm going from Copenhagen, so this is the API call that I have just did. So, following with the Lambda integration, what we are going to do now is try to execute this API call from Postman. As you can see here, I have the URL of the API gateway, and I have a command that I'm going to pass to the API gateway. So this is going to trigger the CLI from the Lambda in an ephemeral way using this command. As you can see here, I have an STS getCaller identity as the one I executed from my computer. But this is different because it has the profile of the Lambda function that was executed. For me to achieve this, I need to build something that's super easy. This is a serverless template that allows me to create the infrastructure. It's like 15 lines of code. This is the Docker image. The particularity in the Docker image for triggering this code is like I'm installing the AWS CLI. So whenever we try to review this log, the incident, if the response team is trying to understand what's the user agent for the call, it's going to look like I executed from my computer. It's not going to be like an automated attack. And this is the code I'm using that I can share with you later that has two endpoints. One to do these commands against AWS, that's like 10 lines of code. And another one to do some ransomish stuff. The thing with this is like, I'm choosing to use this framework because if you go to the configuration of the Lambda, you don't have network logs, so you cannot get me through the network logs. If you don't have the API gateway logs enabled, because I create the API gateway, you are not going to see that. So the only thing that you are going to see here is an event history log from San Pablo with the username of the Lambda function. Is this one. So if I search for the username of the Lambda function, we are going to see all the stuff that I was doing with the function. If I show you the log, you can see that the log is way different. For example, the principal ID don't let you know that this is a role. You're going to see this in the ARN, but the ARN is not always shipped to the SIEM. If you go to see, for example, the username, it looks like an IAM user. If I search in the console for IAM user, we are going to see that this IAM user doesn't exist. This would make the incident responder confused because how is this that they are executing an API call from a user that doesn't exist? If you see the user agent, we are seeing that I'm using an AWS CLI. So this is weird because it's a user that doesn't exist, that is coming from an AWS CLI. And if I try to analyze, to locate the IP location of the request, I'm going to see that the IP location is not more Copenhagen, but is Brazil, Sao Paulo, and the ASN is associated with Amazon organization. So the thing is, like, if we reduce the logs that we are shipping, if we are not integrating all the region, and if we are not shipping all the information that we need, this is going to be super hard to investigate. In the meantime, we are not going to have logs from Garduti, and we can do more nasty stuff. Like, for example, I can try to get the login profile of a user. The login profile is what allows a user to connect to the console. So if the user has a login profile, it means that it has a password. I can execute this command that is delete login profile to remove the capacity of the user of connecting to the AWS console. And I can use the create login profile command to create a new login profile with a different password. In this case, it's first123. So what I would be able to do now is like go to the AWS console. I'm going to grab the AWS account with the user that I have just changed the password. I'm going to use the username that I got. I'm going to add the password that I have just created. And with those commands, I was able to reset a user password from the internet without they knowing. And I was executing this from Sao Paulo, but as IAM is a global endpoint, those logs are going to go to North Virginia, right? So if you're tracking logs from my endpoint in Sao Paulo, you are not going to see this unless you are merging the logs from different regions, and if you are monitoring every region. If you are monitoring only Sao Paulo because your production environment is in Sao Paulo, you are not going to see these logs. Besides this, we can go again here, and we try to go to Garduti in Sao Paulo. And we are not going to see any events. This can happen by different ways. First of all, Garduti has also 10 minutes of delay. So even if it detects me, I have a lot of time to do a lot of stuff, but it's not going to. Another nasty thing that we can do, for example, is to encrypt a file. I could be able to execute an encryption algorithm pointing the other endpoint. For example, I can grab this file that is in an S3 bucket exposed to the internet that is a photo, right? And I can use the same lambda to encrypt the bucket with the command encrypt. If it goes well, it's going to return a 200. And if we go to the bucket that before had only a photo, now I have the ransom note. If I want to go to the URL of the bucket, I'm going to see that the file is encrypted and I cannot access it anymore. Again, the API call is going to come from within AWS, and it's going to be from an ephemeral API call. If I execute, as lambdas last only for 15 minutes, if I execute API calls with sufficient time within API calls, you are going to have also different IP addresses. So it's going to be hard for you to track me from the IP address. So we cannot also, we shouldn't also trust the IP addresses. Again, there are logs that we need to enable for we to be able to detect this. An example of this is what happens with the object within the S3 bucket. As I told you, we have this shared responsibility model, right? S3 is a storage service that is a PaaS platform that should be managed by AWS. But what is inside the bucket is our responsibility, and we need to enable the logs that track what happened with every object that is inside the S3 bucket. This means that if I encrypt a file without touching the bucket, you're not going to get the log of the action of encrypting the file. In order for you to do that, you need to enable something that's called data log, data events. That's in CloudTrail. And if I go to the trail I'm using, that's this one, you're going to see that we are tracking the data events. So if I have this enabled, I'm going to see this, but in the S3 bucket. I'm not going to see this in the event history. So it has 15 minutes of delay. If I have 15 minutes of delay, I could be able to run this command that's put event selectors. The put event selector, what it does, it resets the parameters that I set to the CloudTrail log. So if I run this, what it's going to do is going to reset the configuration of the CloudTrail trail for it to stop logging the data events. So if you are not monitoring this specific API call, and Garduti is not monitoring this specific API call, I would be able to first, if I reset the page and you go here, the data event disappear, right? So I can first disable the data event and then encrypt the bucket, and you are not going to see that log, and you are going to be expecting to that log. If you don't have a rule to check if data events are not coming, you're going to be in a very, very, very bad shape. So going back to this slide that I told you, this is the most important slide in the presentation. These are the delays. I think this is the first thing that we need to address. We need to understand what are our delays and how we are creating detection rules based on these delays. We need to select our integrations as the SIEM we are using, understanding the risks that are behind the integrations they are creating, and what an attacker can do with these integrations. Most of them told you that they had an out-of-the-box integration to do whatever you want, but they don't talk about these issues. And it's critical, right? Because it gives the attacker a lot of time to do whatever they want. These are the key takeovers, wrapping up and finishing the session. So be aware of the global endpoints. The regional ones and the global ones can be a tool for them to enumerate your network without you noticing. Block the unused regions and resources. So if you are not using Lambda in your production environment, don't let everybody else use Lambda. And take into account the dev environments also, because maybe the data in the dev environment is not critical, but an attacker can compromise the dev environment to then attack other environments of other organizations, or even they can use this to mine crypto or do things that can impact you in cost. Be aware of the shared responsibility model blind spot, like I show you with the Lambda function, because you are trusting Garduti and nothing else. And if you don't have good detection rules and good prevention rules, these kind of attacks are not detected at all. And again, take account on the delays, because I think it's like the elephant in the room and nobody is speaking about that. Yeah, I think that's it.
Santiago, applause. All right, we have some time for some questions. If there is a question, please use the mics. You were super clear.
No, well, if you want to chat about this, or if you think there is something that I can take into account or whatever, feel free to reach me. I think it's a technical session, but I think there is a lot that we can do to improve our detection rules with cloud providers.
Yeah, hey, great job. I thought the presentation was wonderful. It hit on all the main points. I think the one thing to note is that there's still help. I know you talked about the blind spots.
Yeah.
But there's always help somewhere that the team and people that can utilize the services can always get on the back end.
Yeah.
To be able to help identify those resources on the back end is who's using those IP addresses.
That's exactly that. And we need to take into account that those blind spots exist everywhere. It's like we think that we are using cloud because we are in AWS, but maybe you have a Mongo Atlas running, and that also has blind spots. GitHub, Discord, even Slack. It's like, and for us, are false negatives that we are not getting, and that's the issue. And thanks for the question, because the main issue working an easier response is not when you get the alert. It's when you get the bucket compromise and encrypt, and then you need to understand why that happened, and you don't have logs. And thank you.
Don't be shy. Please come.
I'm not scary. I don't know why. I'm from Argentina. We are not mean.
Hi, great talk. I just wondered why, when you deployed the Lambda script as the backdoor to do the sort of S3 bucket encryption, why wouldn't you just use the Lambda script to talk to the metadata service and take the whole account over?
Yeah, the idea, that's great. Thank you for the question. And I think that the nice thing about this is like it allows us to leave our imagination free. You know, it's like, but all these things, you can do a lot of stuff. There is like, yesterday I learned about an open source tool to do password spraying with this framework. You know, it's like the impact, you can choose the impact you want. The thing is like, Garduti is not going to detect, and if you're not watching, it's a blind spot. So you can like move to servers, you can reset database passwords, you can dump data, you can take the account, you can send phishing emails using SNS. We can stay the whole day doing what bad things can do. But the important thing is like, what can we do as defenders to be aware of this? So if you are like, if you know what you are using and you can block the rest of the thing, and there are ways to do that, there are a lot of more of limitations.
But also thank you, because I didn't know that the IAM logs are only in North Virginia, so I shall go and make sure I've got some.
Thank you very much.
Yeah, hello. Thank you so much for your presentation. That was awesome. There are a few things that we didn't know about before. Yeah, that was quite an eye-opening. One thing that I am curious about is what kind of situation could lead the deployment of the initial backdoor Lambda, and then what can we prevent? What can we do to prevent that to happen in the first place?
Great question. Great question. The most important thing to prevent this stuff is the less privilege, apply less privilege in the IAM management plane part of the AWS, which is easy in theory, but it's super hard in the practice, right? If I have enough permissions, and we can talk about privilege elevation if you want after, I can execute this with 4 or 5 commands if I execute it manually. So it depends on what the level of advanced threat mode I want to do, right? It's like I can create the ECR today, I can create the Docker image tomorrow, I can create the Lambda, and with one day in difference, you are not going to correlate those events, and Garduti is not going to correlate those events. I can automate with serverless, that's going to trigger all the events because serverless is super noisy, and Garduti is not going to detect it in either. So most detection out-of-the-box rules don't have rules for this, and if you have it, it's mostly certain that you're not getting those logs, because, for example, the log that I show you for CloudTrail, normally SIEMs use like the disable trail API. That's the out-of-the-box rule. But the one I show you is not a disabled trail, so they are not ingesting that because it's super expensive, right? So it depends on the environment. You can do it in a more stealthy way. You can do a lot of anti-forensic also. But the most important thing is like the IAM permissions. Without the IAM permission, I can do nothing. And yeah, but it's a topic on its own, talking about privilege elevation. Thank you for the question.
Yeah, thank you.
Thank you, Santiago.
Thank you all. Thank you for being here.